Hello guys, welcome to my YouTube channel Vishwaguru, a problem solver. Today's class, we are going to discuss a numerical on the topic of motion under gravity. Let's go to the numerical. A body falling freely under the action of gravity passes 2 points, which are all 10 meters apart vertically in 0.2 seconds. From what height above the higher point did it start to fall? Okay. This question is illustrated in the diagram. A body falling freely, say from the point O, under the action of gravity. In its path in the downward direction, it passes 2 points, say A and B. These 2 points are at a distance, vertical distance, 10 meters apart. The body takes 0.2 seconds while crossing the 2 points. Okay. This is the main thing. It means that along its downward path, any points, we can take A and B with 10 meter. Okay, that means here also we can take, here also we can take, but only the particular points only, like say here A and B, which are all at 10 meter apart, the body will take 0.2 seconds. If you had taken the 10 meter apart, 2 points somewhere else, the time taken will not be 0.2 seconds. Okay. So here we have taken 2 points A and B, which are all 10 meter apart, in which the body takes 0.2 seconds to cross the distance 10 meter. Okay, that means A and B. Then we have to calculate from that point A, what height above the higher point did it start to fall. That means we have to calculate the distance OA. Okay, that we are going to take as H. This we have to calculate. Okay. Actually, this motion is the downward motion. This we are going to take as 2 segments. One is AB and another one is OA. Okay. First, I am going to consider the segment AB. So here, the initial velocity, I'm going to take as U1, which is at A. The final velocity, that will be B. Okay. That will be the velocity at B. The distance will be 10 meter. The time taken by the body to cross this 2 point A and B, which are all at a distance 10 meter. That is 0.2 second. Okay. So I'm going to consider this segment. After that, I'm going to consider the segment OA. Okay. After finding that initial velocity or velocity at point A. Okay. Here, both the segments, that means OA and AB, both are the downward motion. So here, for the reference purpose, I'm going to write the formulas which are all used in the motion under gravity. Okay, that kinematic equations I'm going to mention here for our reference. This is a downward motion. So in this downward motion, the kinematic equations, that is V equal U plus GT. We can write S or H, that equal to UT plus of GT square. V square equal U square plus 2GS. Okay. Among these three equations, whatever the equations are, as per the given data, and to find the factors required in this numerical, we can utilize the equations for our calculation purpose. Here, as I mentioned earlier, I'm going to take the segment AB. Here, A is the initial. Okay, so in this first segment, I'm going to take as this is the initial velocity U. B, that is the final velocity. That means velocity at point A is U, velocity at point B, that is V. Then this 10 meter, I'm going to take as S. Okay, that is 10 meter here. Time taken to cross this 10 meter, that is 0.2 seconds. So I'm going to mention the 0.2 seconds. Okay, here. So first, I'm going to consider the segment AB. Okay. This is a downward motion. The required formulas are already we noted at the sites. Here I'm going to find the value of U at what velocity it crosses the point A. Okay. So here we know the value of S, 10 meter. We know the value of time, 0.2 seconds. This is the time taken by the body to cross AB. And we know the acceleration due to gravity, G also. So it's better use the second equation, that is S equal UT plus half GT square. Here we are going to find U. Okay. So substitute all the values except to U. So first S, that is 10. U is that unknown which we are going to find. T 0.2 plus 1 by 2 multiplied with 9.81 and T 0.2 square. Okay. So we can write this 0.2U, or otherwise by simplifying this, okay, we will get the value of U that equal to 49 meters per second. Okay. 49 meters per second. So this is the velocity at point A. Okay. So first we have taken the segment AB. The distance is 10 meter, time 0.2 seconds. Then in this motion, substitute all the values. So by simplifying and calculation, we get the value of U that equal to 49 meters per second. Now I'm going to consider the segment OA. Okay, the segment OA. OA is also the downward motion. Okay. Here we have to calculate what height above the higher point. That means O from the point A. Okay. When it start to fall. That means this H we have to find. So in this segment OA, now I'm going to take, this is the initial velocity. So that is U1. In the segment OA, I'm going to take, this is U1, the velocity at point O. And here we can see this is a free fall, falling freely from the point O, which is at an unknown height, h from the point A. It's a free fall, so its initial velocity or velocity at point O, that is 0. Okay, meters per second. Here we calculated the velocity at point A. Now for the segment OA, the motion in OA, the velocity at point A, that will be the final velocity, which is equal to U. Okay, the final velocity V1 that we calculated in the previous case, that is 49 meters per second. Okay. And we don't know the value of H. And it is also the downward motion. We know the acceleration of due to gravity in this motion, OA, that is also plus G. So we are going to find the value of H. We know the initial velocity, final velocity. That means as per the notation, this will be the H or S1. Okay, U1, V1, S1. This is the acceleration due to gravity. So it's better to use the third equation, V square equal U square plus 2GS. Okay, so I'm writing that equation, V square equal U square plus 2GS. Here S only we need. So just to rearrange the equation, we can write 2GS that equal to V square minus U square, and S equal V square minus U square divided by 2G. So S1, which is equal to H, that equal to V1 square minus U1 square divided by 2G. Here V1, that is the velocity at point A, which we calculated here, that is 49 meters per second. So 49 square minus U1, that is the initial velocity from where it is going to fall. Okay, so that value equal to 0. So here we can substitute 0 square divided by 2 multiplied with 9.81. By simplifying this, we will get the value S1, which is equal to H, the distance from A to O. Okay, the distance OA, that equal to 122.5 meters. Okay, so here the height that equal to 122.5 meter. Okay, so this is the height from what the ball has to fall downwards. Okay, once again I repeat the procedure, what are all the things we did here. Here a body is at point O. From the point O, falling freely under the action of gravity. In its downward path, it crosses 2 points, say AB, at somewhere else. These 2 points are at a distance 10 meters. These 2 points are at a distance 10 meters. While crossing these 2 points, it has taken 0.2 seconds. As I mentioned earlier, when a body falls downward from a height, here finally we calculated a distance 122.5 meters. Okay, so it's a large distance. So in this 122.5 plus 10, okay, so in this vertical height, we can take any 10-meter distance, but all the 10-meter distance and all, the body will not take 0.2 seconds to cross the points, which are all at 10 meters. It will take 0.2 seconds. Only these particular points, which are located at a distance 10 meters. Okay. So here we have to calculate from the point A, that means, or the distance 10 meters, the point where it starts its motion, that is at what height in vertical direction. That h we have to calculate in this numerical. This we split it into two segments. One is AB and another one is OA. First, AB. It's a downward motion. S equal ut plus of gt square. Here, this S, that is 10 meters. U is here the velocity at point A. The time taken is 0.2 seconds. By substituting all the known values, we calculated U equal 49 meters per second. That is the velocity at point A. After that, consider the segment OA. That's also the downward motion. At point O, it is a free fall. So these segments I'm going to mention with all the values with a suffix 1. U1 equals 0. It's plus G. The sketch OA distance, that is S1. The velocity at point A, U, which we calculated here, that is the final velocity in the segment OA, that is V1. Then we had taken the third equation and derived this for S, V square minus U square by 2G. Then substitute the known values. Then we calculated S1, that is 122.5 meters. That is the height of the point O, where the body falls freely from the distance 10 meters or from the point A. Okay. I hope you all understand this numerical. And guys, don't forget to subscribe, because in further upcoming videos, we are going to discuss many numericals belongs to the topic motion in straight line, motion under gravity, D'Alembert's principle, Newton's law of motion, connected bodies, etc., etc. in engineering mechanics. Okay. So don't forget to subscribe my YouTube channel, Vishwaguru, a problem solver. Okay, guys. Thanks for watching this video. Thank you.